All right, so let's go with solving absolute value inequalities part 2. All right, so sorry, my phone, somebody called in, so it cut out. All right, so now we've already isolated our absolute value just like we isolate a variable. So now the only way to get rid of the absolute value bars is to set this expression equal to the positive and equal to the negative. All right, so we are going to have 5x minus 7 equals 3. And I'm going to set it equal to 5x minus 7 equals negative 3. Okay, I'm going to move that up there. All right, so we have to solve each of these. Well, these are simple equations. We're going to add 7. What you do to one side, you must do to the other. That brings it down to 5x equals 7 plus 3 is 10. Divide by 5. X equals 2. All right. Now on the other side, we're going to add 7 again. 5x equals 4. Divide by 5. X equals, and I'm just going to leave it as 4/5 instead of worry about changing it to a decimal. So I'm just going to leave it right there where it's at. All right, let's do another one. So we should be pretty good with, as long as you keep the mindset that the absolute value bars are just a variable, and so you want to isolate that by itself and then work the problem, you'll be just fine. But we do have a special case, or you might run into one like this. So I want to show you now. 6 plus 5, 2x minus 5 equals negative 8. All right, remember, the first thing we must do is isolate that absolute value. So once again, if you have to put something over, do it. So that marker cover is my variable. So what am I going to do first? I have to subtract 6, because remember, this 5 is being multiplied to that. Subtract 6. Takes that away. And then I have 5, absolute value bar. 2x minus 5, absolute value. Negative 8 minus 6 is negative 14. Now we're going to divide, remember, because it's 5 times the absolute value. So we're going to divide by 5 on each side. Absolute value of 2x minus 5 equals negative 14 over 5. Now, if you've noticed before, every time we have an absolute value, it equals a positive number. Okay, so let's look. Where's my other problem? It's right here. The absolute value equals a positive 9. By the time that we isolated the absolute value, it equaled a positive number. Okay? It doesn't have to start out with that, but when the absolute values are isolated, it must be a positive number. Okay? Now, with that, this one is not. So what happens? Well, it's no solution. You cannot go any farther. No solution. Absolute value measures distance. Therefore, the AV, or absolute value expression, cannot equal a negative number. Okay? The absolute value expression cannot equal a negative number. That is the rule. So if you isolate your absolute value bars and it gets to this, then it's nothing. You're done. It's no solution. All right? Let's look at another one. 5 minus 4, negative 2x minus 8 equals 5. All right, once again, if you think about the absolute value being your variable, we have 5 minus 4x equals 5, okay? So we are going to subtract 5 from both sides. That's gone. That leaves me with a negative 4 absolute value. Negative 2x minus 8 equals 0. So now we're going to divide by negative 4. So you have the absolute value of negative 2x minus 8 equals 0. All right. So at this point, I told you earlier that 0 is neither positive or negative. I was able to isolate my absolute value. Okay, I have a 0. It's not a negative number, but I will only have one solution. Because there is no such thing as a negative 0. Okay, there's no such thing as a negative 0. So we are just going to take our negative 2x minus 8 and we're going to set it equal to 0. So then how do we solve it? We got a two-step equation. Add 8. What you do to one side, you must do to the other. That leaves us with negative 2x equals 8. Divide by negative 2. Negative 2. X equals negative 4. Okay. Now, this is another part of the notes that I want you to take time, hit pause, copy down the notes, and then come back and we will discuss it. And we're only going to work 2 examples once you're done. All right? I'm going to assume we're all back here. Steps to solve an absolute value inequality. Number 1, isolate the absolute value expression. Okay, we know how to do that. Number 2, move the absolute value expression to the left side of an inequality. Now remember, these are the rules for an inequality, not an equation. So the rules that we were looking at earlier, these steps were absolute value equations, okay? Now we are dealing with absolute value inequalities. So we're going to isolate the absolute value expression just like we did with the equations. We're going to move the absolute value expression to the left side of the inequality. We're going to rewrite it as an and or an or statement. And then we're going to solve the variable using the steps for a compound inequality. So an and statement. An and statement, when you move your absolute value to the left, it's going to be less than or equal to. Which means we're going to set the negative C at the front and the positive C at the back. And we're going to keep the less than signs in the center. And then when you have less than or equal to, we're going to have our negative C on the left, our positive C on the right, and we're going to use the less than or equal to signs, and we're going to put our absolute value expression in the center. Okay? An or statement. An or statement, when your absolute value expression is on the left, it is greater than or equal to. But the difference with or is you're going to say that the absolute value expression is less than negative C or it's greater than C. So you see, remember when I told you you had a multiply or divide by a negative, you flip the sign? Well, we actually switched this to a negative, so you have to flip the sign. Same thing here. The absolute value greater than or equal to C. So we have this that's greater than or equal to C. But since I'm going to make it a negative C, I have to flip the inequality sign. Now, this piece of paper right here is this section where it says and or. This is a section that you're going to refer back to several times while you're doing your homework, and that is okay because that is the learning process to make you understand it, all right? So this is the part I want you to refer back to. All right, so let's do two. We're going to do one example of an and statement and one example of an or statement. Once again, it's not near as bad as what you're thinking. We're going to be able to handle this. Here we go. Example 1. Now, remember, we are dealing with inequalities now. So I have the absolute value of x minus 3 is less than or equal to 4. All right. So, what do we need to remember? Well, less than or equal means that this is an and statement because we just looked back at our notes and saw that. Okay? Less than or equal to means that it's and. So, now my absolute value sign, my absolute value bars, is it isolated? Yes. Is it on the left side of the inequality? Yes. So now I just have to set it positive or set it equal to the positive and the negative. Well, this is how I work it, okay? I'm going to say x minus 3 is less than or equal to 4. And then on the other side, I'm going to say x minus 3 is greater than or equal to negative 4. Because I am going to flip the sign due to the answer being negative. I'm going to flip the sign due to the answer being negative. Okay, so now we solve. And we solve using all the same rules that we know. We're going to add 3, x is less than or equal to 7. Add 3, x is greater than or equal to negative 1. All right, so we have our two answers. How do we write this as a compound inequality? We have x is greater than or equal to negative 1 and x is less than or equal to 7. All right, well, what do we have in common? The x. So I write my x down. Now, I write my smallest number on the left and my largest number on the right. So what's my smallest number? Negative 1. What's my largest number? 7. Just like a compound inequality, guys, listen, look at the way your arrow is pointing. So this one right here, my inequality sign is pointing towards the negative 1, so I must keep it pointed towards the negative 1. Points towards the negative 1, points towards negative 1. This one, when you're looking at between the x and the 7, is pointing towards the x. I must keep it pointing towards the x. So that is how you would write your answer. Not too bad. Example 2. We're almost done. So we have the absolute value of x minus 20 is greater than 5. Now, we know initially when my absolute value sign is isolated by itself and it's on the left-hand side, the greater than means it's an or statement. Okay, so now what do? Well, we have to solve it using that it's an or statement. So we're going to say x minus 20 is greater than 5. But we have to flip it over here. X minus 20 is less than negative 5. You have to flip the sign because you make it negative. And now we solve. Plus 20, x is greater than 25. Over here, plus 20, x is less than 15. Now, the only thing about your or statements is you must write them least to greatest. So this is my numbers, looking at just your numbers. So we're going to say x is less than 15. I'm just bringing this down. Or, and I'm just going to bring this over here, x is greater than 25. All right, it's time to complete our homework. Listen, I'm going to be available to answer questions, but you must use your notes on tonight's homework. You must follow through the steps, okay, to make sure that you are solving these and isolating this absolute value expression the way that you should. And then on the and and or statements, making sure you're paying attention to the signs if it's an and or an or statement. All right, talk to you later.